I know, don't we just love a multiplying and dividing by 10, 100 and 1,000 video? You're not really looking at that, are you? You can see Tigger. I know, that's where you're looking. You're going to go, what on earth is this guy on talking about Tigger? And what you can't see is my dog is currently looking at me with those soulful Tigger eyes, and I'm just about to ignore him and put all of you guys out there in internet land first. Okay, if that's not animal cruelty, nothing is. Right, we not only need to know how to do our times tables, ladies and gentlemen, but we need to know how to use basic number facts to help complete questions quicker. Mathematicians are lazy. We want to do things as quickly as we possibly can. And one of those most important is being able to multiply and divide by 10, 100 and 1,000 and 1 million and 10 million and all other numbers ending in 0. Now, the way I tend to teach this, and undoubtedly there are teachers in the United Kingdom and the primary school going, what are you doing? We no longer bounce the decimal, we actually move the numbers. Well, I'm really sorry, guys, that makes no sense to me or the rest of humanity. So, I'm going to stick with a bouncing decimal point. So, which of the following is cute, and which one is a killer? Well, hopefully the cute one is my wonderful little friend there called Tigger. And the killer, believe it or not, is this wonderful little fluffy creature here called a kangaroo. Alright, now, whether you know it or not, kangaroos are actually quite dangerous. Their kick can kill. So those of you who are around the world watching this video and think that coming to Australia and cuddling a kangaroo would be a good idea, please don't. That would never be a good idea and it would end quite badly. But anyway, what do they have in common? They bounce. Yes, and of course, I found this wonderful thing on the interweb. The wonderful thing about tigers is the tigers are wonderful things. Their tops are made out of rubber. Their bottoms are made out of spring. They're bouncy, bouncy, flouncy, pouncy, fun, 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 fun. The wonderful thing about tigers is that I'm the only one. There we go, and it goes on, but I'm not going to sing anymore, right? Because those of you who do not love Tigger, really, probably need help. So, bouncing decimals is the most important thing here, and so we are looking at everything to do with that decimal point between numbers. Now, let's just watch what happened. These are some really basic examples that I've already written out for you. So when we do 6 times 10, we know, hopefully, that the answer works out to be 60. And when we do 36 times 10, we get our answer as 360. Now, the wonderful thing here is that I know so many of you go, well, when I do 6 times 10, my teacher just said, put a 0 on the end. And I'm like, what? They're like, put a 0 on the end. And I'm like, really? Well, that terribly disappoints me because imagine what happens if I have 0.4 times 10. What is 0.4 times 10? Well, using your rule, I would get 0.40, which, if you know anything about decimal points, you don't need the zeros at the end of a decimal number. And you've just told me that taking the 0.4, multiplying it by 10, gives me 0.4. That's almost as bad as telling me that a half times a half is 2/4. And if you think that is correct, when you cancel that down, you're telling me that when I add half a cake and a half a cake, I'm left with half a cake. Now, in that case, I'd be asking who stole my half a cake. Give it to me back right now. But basically, there is a mistake here. This shortcut of quote unquote putting a 0 on the end of numbers is horrible. So let's actually go back to what is happening when we multiply by 10. Well, here we go. Now, what you've got to remember is that 6, as I've said here, is the same as 6.0. Right? We can put a decimal and a 0 at the end of any whole number. So, 7 becomes 7.0, 8 becomes 8.0, 12 becomes 12.0. When we multiply by 10, what actually happens is that decimal point moves. Look at it. The decimal point has now moved to after the 60. After the 6 and before the decimal point. How? Well, look, as I've done here, that decimal point jumped one place. Why does it jump one place? Well, basically, 10 has 1 0. And for every 0, the decimal point jumps that number of places. And that's what I've said here. The number of zeros tells you the number of places to jump. So, let's have a look one more time. So here's an example, here's another example, here's an EG2. 3.24 times 10. Right, so we've got 3.24 times 10. When we times, the decimal point jumps to the right. How many zeros do we have? Because that's really important. We have 1 0, so it is in fact going to jump 1 place. 3.24. Ready? There we go. So it's now moved to be between the 2 and the 4. And the 3 stays. So 3.24 times 10 is 32.4. Wow. All we're doing is moving these decimal points. Absolutely. And as I've said here, with my big warning sign and now a big star, we do not just put a 0 on the end, people. Right? And for those of you who want to know, here we go. I've used that exact example again. If I jump, or if I put a 0 on the end, I get 0.40. That last number, that 0 at the end of a decimal number, so zeros at the end of a decimal number, can be ignored. Why? Well, because 0.4 is the same as 0.40, 000, 000. I can keep adding zeros onto the end of this number, and it will still be the same number. If I was to, for example, now put a 1 after there, it's a very different number. So let's not put the 1 after there. But we can put zeros as many as we like. But more importantly is if there's lots of zeros, I can actually ignore them and get rid of. So let's do some examples. 23 times 10, remember. Sorry, 23 times 100, in fact. So we're going to do 23, and I'm going to put my decimal point and 0 on the end. Why? Because it's a whole number, and I can do that. It'll help me see the decimal point and know how many spaces to jump it. So we're doing a times, so we're going to jump that way. And 100 has 2 zeros, so I'm going to jump it 2 places. Are we ready? Oh my goodness gracious me. Now we have a problem, ladies and gentlemen. What is our problem? Houston, Houston, we have a problem. Well, we seem to have jumped over a gap. Well, I always say, what is there? And my kids go, well, there's nothing there. And I go, exactly! There is a nothing there. So every time you jump over a gap, you put nothing there. So my decimal point is now at the end. Let's go to this arrow, and we'll make it a little bit shorter. Here is my decimal point now. So there is a 0, and there is a 0, and there is a 3, and there is a 2. Now remember, that decimal point is no longer there. It's now at the end. Would I write my answers 2300 with just this dot on the end? Nope. And if I have this floating decimal, I can actually get rid of it. So 23 times 100 is in fact 2,300. The crowd goes crazy. 8.6 times 1,000. Well, we're timesing. It's going to move that way. It's got 3 zeros, so it's going to jump 3 places. So let's see what happens. 8.6. There is my decimal point. I've jumped 3 places. Oh no, I've got gaps. I've got gaps. There's nothing there. Well, actually, yes, there is nothing there and there is a nothing there. So here's my decimal point. 0, 0, 6, and 8. Do I need the floating decimal at the end of it? I do not. Thank you very much. I should go. We'll leave it alone. And so the same look, 0.345. Now we have a decimal number with a 0 in front of it. Does the rules change? No, it does not. We're timesing, so I'm going to move the decimal point to the right. And there's a big hint coming here. Wonder what happens when we divide. We move to the right. We have 4 zeros, so I'm going to move it 4 places. Are we ready? Write the number out just to help me. 3, 4, 5, 1, 2, 3, 4. There is where my decimal point finishes. I have a gap. There's nothing there. Yes, there's nothing there. So here's my decimal point. 0, 5, 4, 3, and 0. That looks a bit weird, don't you think? Well, firstly, we know we can get rid of that decimal point. Thank you very much. But what are zeros at the start of numbers? We knew earlier that we could get rid of all those zeros at the end of numbers. But what about at the start of numbers? Well, if you have a 0 at the start of whole numbers, same thing. You can actually get rid of it. Now, again, I said whole numbers. This is not a whole number. It's a decimal number. So anybody here who tries to delete that, I will cry. Buckets, which will, unfortunately, just leave me bereft. Great word. All right. So you can get rid of zeros at the start of whole numbers and at the end of decimal numbers, but not any other time. So here are some questions for you to do. These questions came from the Mathletics resource, which is another fabulous resource, and no copyright infringement was intended. These questions were just great resources for my Year 6 students to do, or my Year 7 students to do, in fact. So here we go. There are questions for you to do. Have a go at them, and I will give you the answers. Pause the video now. And welcome back to our answers. Hopefully you've unclicked pause now rather than stop my video. What have we done? So we've moved the decimal point right 2 places. Here we've moved it right 1 place. Here right 3 places. Here right 4 places. Right 2 places. And right, wow, that's a lot, 6 places. So check your answers. Hopefully you got those right answers. Now what about division? Well, it's just a jump to the left. Now, you guys undoubtedly are way too early to watch a film called The Time Warp. This is way back when I was a kid, and even then it was a little bit like, oh, this is a weird movie, but it's got a great song. What I advise to you is load up The Time Warp on YouTube. Load up the video of The Time Warp and start playing it. And if your mum and dad don't jump up and start doing the most random dance moves, they really need to, well, actually jump up and do some random dance moves. But the point of it is, when we divide, we actually jump to the left. Now, why? Well, maths is done both forwards and backwards. Remember, when we times by 100, we moved our decimal point 2 places to the right. So it would make sense that if I was going to divide by 100, and divide is the opposite to times, I'll actually move it 2 places to the left. And wow, mind blown. This is now awesome. So here are some examples. 340 divided by 10. So 340, where is the decimal point at the moment? It's at the end. And I'm going to divide by 10, which means I'm going to move it left 1 place. Ready? So the decimal point is now between the 4 and the 0, and the 3 is there. Do I need the decimal point and the 0 at the end of the number? I should cocoa not. And so my answer becomes simply 34. Now, I'm sure there's a shortcut that just says remove a 0 from the end. That just terrifies me. All right, again, how are you going to do this? If you had 0.4 divided by 10 and you're going to remove a 0 from the end, well, I don't know about you, but can you see a 0 at the end? Well, yeah, probably if I do this and put a 0 on the end. But then what? I'm going to remove it again and I end up with the same answer? Nah, these shortcuts make no sense to me at all. Here's the second example, 28 divided by 100. Write the answer out, write the question out, put the decimal point in. Divide is going to be to the left. Oh, not 1 place, what am I thinking? 2 zeros, 2 places. So, there's the decimal point, there's the 2 and there's the 8. Do I leave my answer like this? No, we are not a restaurant here in Melbourne on Swanson Street. We actually believe in the value of 0. No pun intended. You see what I did there? Value of 0. Anyway, 0.28. You can't just leave a decimal point floating. And you're going to say, yeah, but you said I can get rid of zeros at the beginning. No, I didn't. I said if you had a whole number with a 0 in the bit at the front, you can get rid of it, but not any other time. And lastly, oh, this is going to be interesting, 0.34 divided by 100. I'm going to move it to the left, 2 places. There's my decimal point. Oh my goodness, what have I got? What have I got? What have I got? I've got a gap. I've got a gap. I don't know. What's there? There's nothing there. Oh yes, there is nothing there. So there is my decimal point. There is my 0. There is my 0. There is my 3. There is my 4. And because we can't have a floating decimal at the start, we're going to put a 0 in. Oh, you surely have got this by now. Last one. Last example. We're going to move it left. This time 4 places. And I chose a really long number. 283840. So we're going to move it 4 places. Where is the decimal point? It's there. 1, bang, 2, bang, 3, bang, 4. My decimal point is going to end up between the 8 and the 3. So I'm going to write all the rest of the numbers just to make sure that I don't make a mistake. And do you notice how I write the numbers backwards going that way? Weird, huh? It's just so I don't make a mistake. Right, is that my final answer? No, it is not the final answer because I have a 0 after the decimal point, so I can get rid of it. And ladies and gentlemen, there we go. So here are some questions for you. Once again, Thank you very much to the Mathematics Resource for providing some fabulous results, and no infringement of copyright has been intended. All right, hopefully you will allow me to continue to use these amazing questions. Okay, so here we go. Calculate these divisions, have a go, and I will give you the answers in just a moment. And welcome back, here are our answers. So 0.02, now remember we are dividing, so we're going left 2 places. 4.59, so we're going to go left 3 places, and remember that 0 on the end disappears. This one here is interesting, 0.014, dividing by 10 jumps over. Decimal point is now at the front, so we have 0014, and we can't have that floating decimal. This 70.80, I'm going to do over here, 70.80, we are dividing by what number? 10,000, so we're going to move it 4 places, 1, 2, 3, 4, there's a point. I've got 2 nothings there, 7080. We have to put a 0 at the front there, and we can get rid of that 0 there, which gives me the 00708. And to be fair, the rest of the questions are exactly the same. Now, in maths, we try and make things easier for ourselves. We are crazy lazy, right? Because we try and come up with what we call notation that sort of writes long numbers in easier ways. Now, obviously, when we multiply by 100, that's not too difficult to write. But what if we were to multiply by 1,000,000 lots and lots of times? Well, there must be a quicker way of writing 1,000,000. There probably has to be a quicker way of writing 100. And actually, it comes down to this subject called floaty numbers. Now, otherwise known as indices or powers. Now, I call them floaty numbers because they is numbers what float. Let's do a little bit of an aside again, and as you can probably imagine here, this lady is, yes, she is floating a little image to tell us that we are floating numbers. If we have 2 times 2, we know the answer to that is 4. And 3 times 3 is 9. And let's just start with 1 times 1 is 1. And 4 times 4 is 16. And 5 times 5 is 25. And these go on. Now, if you have learned anything with me recently, you know the numbers 1, 4, 9, 16, 25, 36, 49 are called square numbers. Ooh, nice. Now, we don't want to keep writing square numbers as 1 times 1, 2 times 2, 3 times 3, 4 times 4 times 5, 5. So we can actually write these in an easier way. So we can say that 1 times 1 can actually be written as 1 with a floaty 2. Now that does not mean 1 times 2. We can write 2 times 2 with a floaty 2. We can write 3 times 3 as 3 with a floaty 2. And 4 times 4 as 4 to the floaty 2. Now, let's just see, what would I write 2 times 2 times 2 as? Well, funny enough, we'd write that as 2 with a floaty 3. And 3 times 3 times 3 would be 3 with a floaty 3. And 4 times 4 times 4 would be 4 with a floaty 4. No. With a floaty 3. Got carried away. Now, the floaty number is actually just telling us how many times to write the big number, with a times in between it. So if I had 6 to the floaty 4, I'd end up with writing 6 times 6 times 6 times 6. Much shorter to write 6 with a floaty 4 than 6 times 6 times 6. Well, what does that have to do with the price of fish? Well, we've been dealing with numbers that are 10, 100, 1,000, 10,000, what else? 100,000, lots of zeros, 1,000,000, and we'll stop there. Now 10, well, we'll come back to that in a moment, but 100 we know is 10 times 10, and 1,000 is 10 times 10 times 10, and 10,000 is 10 times 10 times 10 times 10, and 10 times 10 times 10 times 10 times 10. Well, we've now realized that when we're writing the same number with lots of times in between, we can actually write it in a better way, or at least a quicker way. So 100 can be rewritten as 10 to the floaty 2. Wow! Because we've written 10 times 10. And 1,000 is 10 to the floaty 3. Wow! Because it's 10 times 10 times 10. And 10,000 is 10 to the floaty 4. And 10 to the floaty 5. And 1,000,000 is 10 to the floaty 6. Well, if we look at the pattern, we've got 6, 5, 4, 3, 2, and so that must be 10 to the floaty 1. All right, now generally speaking, all numbers should be written with a floaty num, 1. So it should be 4 to the floaty 1, and 5 to the floaty 1, and 6 to the floaty 1, and 7 to the floaty 1, and 8 to the floaty 1, blah, blah, blah. But we don't. We don't need to write floaty 1s because it's just saying there's one of them, right? So 10 to the floaty 1 just means 10, whereas 10 to the floaty 2 means 100. Okay, so we could now say, for example, that 3.6 times 100 can be rewritten as 3.6 times 10 to the floaty 2. Why? Because 100 is the same as 10 times 10. And we know that can be rewritten as 10 with the floaty 2. Ooh. And 3.147 times 10 to the floaty 4 would it be exactly the same as 3.147 times 10 times 10 times 10 times 10. And we know that 10 times 10 times 10 times 10 is 10 to, 10,000. Now, not that I like to deal with shortcuts, but what do you notice? The floaty number actually stands for the number of zeros as well. Now that makes me nervous, but in this situation it seems to work. So we've got 1 0, floaty 1, 2 zeros, floaty 2, 3 zeros, floaty 3. We can actually use this information to answer some questions. Now I'll do the first one for you, and then the rest are over to you. All right, so 31 times 10 to the floaty 2. I now know that can be rewritten as 31 times 100 because it's got those 2 zeros. And now I can do that. And remember, in this situation, it's a times. It's trying to trick you. There are different questions, times and divide. So make sure you don't get tricked by the questions. And I'll rub all those out in a moment to make them clearer. So that is 31. There's my decimal point. Our times means I move to the right 2 places. And so, there's my new decimal point. There's a 0 and a 0 because there's nothing there, a 1 and a 3, and I don't need the decimal point after there. So this one here is 3100. Rub this out for you. Over to you. Have a go and pause the video, and I'll give you the answers in just a moment. Welcome back. How did you get on? Well, here we go. There are your 6 answers. So remember, with the dividing, we're going to move it back. 10 to the 5 is nothing more than 1 with 5 zeros. This is a time, so we're going to move the decimal point to the right. How many places? Well, 10 to the 6 is 1 and 6 zeros. Times, move it that way. 10 to the 4 is 1 and 4 zeros. So that will jump it 4 places. Divide goes that way. Whoops. 3 places. Why? Because that's effectively 1,000. And divide go that way 7 places, which happens to be 10 million. Okay. Well, there we go, guys. Hopefully you've understood this and have been able to get some questions right using it, right? This floaty number stuff is really, really important. And remember, 7 squared does not mean 7 with 2 zeros after it, right? That only works with tens. 7 squared is the same as 7 times 7 because the floaty 2 tells you to write the number that many times with the times in between it. Okay, lovely seeing you as usual. Look forward to seeing you next time. It's been so great having you watch this video that I'd like to see you again and again and again. Wow, we could make some amazing maths together. So, if you'd like to, and you'd like to be updated as to when I upload new videos, why not subscribe by clicking the button on the right? Otherwise, if you want to click and see another video created for this type of series, then click the video on the left. Alright, well, you have an awesome day, and I look forward to seeing you again.